We begin with the weather and millions of Americans bracing for rain, wind, and possible flooding. There's also a risk of more massive waves like the ones that slammed the California coast, some as high as 25 feet, damaging homes and prompting evacuation.
The parking lot disappeared in seconds, not gradually, not with warning, but all at once, as a wall of white water exploded over the seawall and consumed everything on the other side: cars, benches, a row of rental bikes. Gone. The ocean did not announce itself. It simply arrived, and it took what it wanted. That is what is happening right now along more than 1,000 miles of American coastline. From the sun-bleached shores of Southern California to the rain-soaked cliffs of Washington state, the Pacific Ocean has entered a violent and sustained assault on the land. And the people who study these things for a living are not using words like unusual or significant. They are using words like historic. They are using words like historic. They are using words like dangerous. And some of them are saying, quietly but clearly, that what we have seen so far is not the worst of it. This is not a tsunami. It is not a hurricane making landfall. It is something that operates on a longer timeline and covers a wider geography, which in many ways makes it more insidious, because it does not announce itself with a single catastrophic moment. It builds, it persists, it returns. And by the time most people realize what they are dealing with, the water is already over the wall. Part 1. What is happening right now? The warnings began arriving late last week from the National Weather Service. High surf advisories, stacked one on top of another, stretching from the Mexican border to the Canadian line. Not a localized event, not a single storm, a sprawling atmospheric and oceanic system that has been feeding enormous energy into the Pacific for days, pushing swells of extraordinary size toward a coastline that was never built to absorb them. By Saturday morning, those swells had arrived. In Santa Cruz, lifeguards closed the main beach entirely. The waves breaking there were measured at over 20 feet on the face, crashing with enough force to vibrate the concrete observation platforms above. Spectators who gathered to watch were repeatedly drenched by spray that carried 50 yards inland. 2 people were pulled from the water after being swept off a lower viewing area. 1 required hospitalization. Further south in Ventura, a harbor that typically looks like a postcard had transformed into something unrecognizable. Boats that had been secured to their slips overnight were found that morning battered against the dock pilings or dragged partially free of their moorings. The harbor master issued an emergency closure to all vessel traffic. Workers spent the morning collecting debris, cleats, dock planking, personal items that had been scattered across the water. A section of the main dock that had stood for over 30 years broke apart before noon. In San Diego, a stretch of coastal road that runs parallel to the water flooded twice in a single morning. City crews laid sandbags and posted signs. Drivers ignored the signs. The road flooded a third time, and that was only the south. In the San Francisco Bay Area, the situation carried a different character, more industrial in scale, broader in consequence. The bay itself, normally protected from open ocean swell, recorded breaking waves at heights that stunned even veteran observers. Ferry operations were suspended. A shipping company operating out at the Port of Oakland delayed 3 vessels. Emergency managers in Marin County activated their coastal monitoring teams as swells pushed into low-lying areas around the estuary. In Pacifica, a coastal community south of the city that has spent years watching the ocean claimed chunks of its bluffs. The weak surf delivered another message that the sea is not finished with that town. Oregon was next. The Oregon coast operates under different rules than California. There are no lifeguards on most beaches. There are no fences. The ocean is accessible and wild in a way that draws people from across the country, precisely because it feels untamed. That quality, which makes the coast beautiful, also makes it lethal when the water turns aggressive. Sneaker waves, large waves that arrive without visible warning, often after a period of smaller surf, are not a rarity in Oregon. They are a documented, recurring cause of death. This week they came again. 3 people were swept from a rock formation near Cannon Beach within a single 48-hour period. The first 2 were recovered by a Coast Guard response. They were cold and shaken but alive. The third was not recovered. Search and rescue teams continued operating as of the most recent update, covering a coastline that gives back what it takes only on its own schedule, if at all. Washington state, at the northern end of the event, was watching and preparing. Emergency management officials in several coastal counties issued preemptive warnings, urging residents to stay away from beaches, jetties, and any low-lying area near tidal inlets. The Columbia River mouth, one of the most dangerous river bars in the world under normal conditions, was under a small craft advisory that made it impassable for most vessels. The outer coast of the Olympic Peninsula, already one of the most remote and rugged stretches of shoreline on the continent, was hammered by surf that rarely reached that level of sustained violence. The entire coastline had become, in the words of one emergency manager, a no-go zone. Part 2. Why this is happening. To understand what is driving this event, you have to start not at the shoreline, but somewhere in the middle of the North Pacific, thousands of miles to the west. The Pacific Ocean is not a passive body of water. It is an engine, a dynamic interconnected system of atmospheric pressure, wind, and current that transfers energy across hemispheres and shapes the climate of half the planet. When conditions align in a particular way over that vast expanse of open water, the ocean generates swells, long-period swells, the kind that travel enormous distances without losing their structure, arriving at distant coastlines hours or days after the storm that created them has already dissipated. That is precisely what happened here. A powerful low-pressure system, a storm of the kind that forms with some regularity in the North Pacific during winter months, generated sustained winds over a large fetch of open water. Fetch is the term oceanographers use to describe the unobstructed distance over which wind can act on the water's surface. The larger the fetch, the more organized and powerful the resulting swells. This system had both the right intensity and the right positioning to funnel energy directly toward the North American coast. The swells it generated have a period, the interval between wave crests, of between 17 and 20 seconds. That number matters more than it might appear. Swell period is a direct indicator of wave energy. Shorter period waves, in the range of 8 to 10 seconds, contain less energy and dissipate more quickly. 17 to 20 seconds means these waves have been traveling for a long time, organize themselves over vast distance, and are arriving at the coast with maximum force. When a swell with that kind of period reaches shallow water, it does not just crash, it surges, it floods, it carries water far beyond where the casual observer expects it to go. The National Weather Service forecast models had been tracking this system for nearly a week before landfall. The models were accurate, the warnings were issued, and still, on Saturday morning, people were standing too close to the water. That pattern, accurate forecasting met with human non-compliance, is one of the most persistent frustrations for coastal emergency managers. The information exists. The infrastructure for communicating it exists. What is harder to engineer is the gap between knowing a wave is dangerous and truly believing, in the moment when the sky is clear and the beach looks inviting, that today is the day you should stay back. Part 3. The science of escalation. Here is the part that the scientists want people to understand. The swell that has been pounding the coast this week is not a static event. It is not a single large wave that crests and subsides. It is a succession of wave trains, each carrying its own energy signature, each arriving at slightly different intervals and from slightly different angles. When those trains align, when the peaks of two separate swell systems coincide, the resulting waves can be significantly larger than either system would produce alone. This is called constructive interference, and it is one of the reasons that wave heights during a major swell event are not constant. They fluctuate, they lull, and then they spike. That spike, arriving without warning after a period of smaller surf, is what creates the sneaker wave. It is what swept people off the rocks in Oregon. It is what flooded the parking lot in Santa Cruz when beachgoers had relaxed their vigilance after an hour of manageable surf. The ocean was not being deceptive. The ocean does not have intent. It was simply doing what physics dictates. The people watching it were applying human logic. This has been safe for the past hour, therefore it will remain safe, to a system that operates by entirely different rules. Oceanographers monitoring the event noted something in the incoming forecast data that prompted a second round of warnings on Sunday evening. A secondary swell system generated by a separate atmospheric disturbance further out in the Pacific is currently in transit. It is smaller than the primary system, but it is approaching at an angle that will cause it to interact with the backwash and residual swell energy already present along the coast. The resulting interference pattern, according to models, is likely to produce another period of elevated wave heights beginning in the coming days. In other words, this is not over. The primary swell is already here, already doing its damage, already generating the video footage and the emergency closures and the Coast Guard rescues. But the secondary system is still on its way, and the coastline it is approaching is already saturated, already softened, already weakened by days of sustained assault. Bluffs that absorbed the first wave of impacts are now structurally compromised. Sandbags paced by city crews are soaked and partially displaced. Beach berms that act as natural buffers have been eroded. The coast is less defended now than it was at the start of the week. That is the condition into which the next surge is arriving. Part forward. WHO is most risky. Not all sections of the coast face identical exposure. The angle of approach of the primary swell has concentrated the most severe conditions at particular points. Headlands, jetty ends, exposed coves, where wave energy is focused rather than dispersed. Rocky intertidal areas are among the most hazardous locations during a high surf event. They attract curious visitors, tide pool explorers, photographers. They offer what appears to be a vantage point above the normal wave zone. But during a major swell, that vantage point becomes a trap. Waves can run up rock surfaces at speeds that make retreat impossible. The footing is slick. The next wave arrives before a person can recover from the last one. Harbour entrances are a separate category of danger. The geometry of a jetty or breakwater mouth concentrates incoming swell, producing conditions that can destabilize even large vessels. Several California harbours remained closed to small craft through the weekend. Recreational boaters were warned not to attempt to navigate harbour entrances regardless of how the conditions appeared from inside the protected basin. What looked manageable from within the harbour can, at the mouth, be actively dangerous. Low-lying coastal neighbourhoods, particularly in areas where development extends close to the high tide line, face flooding risk that persists even after the peak of the swell has passed. Swash zones shift during major events. Water finds new paths. Roads that flooded once are likely to flood again. Residents in these areas were advised to move vehicles to higher ground and to avoid crossing any water of uncertain depth. And for the general public visiting the coast in the coming days, the water does not look different when it is dangerous. The sky may be clear, the air may be warm, the waves may have been smaller for the past 20 minutes. None of that is a reliable indicator of what the next set will bring. The only reliable guidance is the official advisory. If it says to stay back, stay back. Part 5. The bigger picture. There is a longer conversation embedded in this week's events, one that coastal scientists and planners have been having for years with increasing urgency. The west coast of the United States is not getting more protected from the ocean, it is getting more exposed. Sea level rise, even at current measured rates, is altering the baseline from which every swell and tide operates. A coastline that absorbed a 20-foot wave in 1985 without flooding now faces that same wave from a starting water level that is measurably higher. The physics of coastal inundation are not forgiving. Small changes in baseline water elevation produce disproportionate changes in flood extent and frequency. At the same time, the atmospheric systems that generate large swells in the North Pacific are operating in a climate that has more energy available to them. The scientific literature on this is not unanimous. The relationship between climate change and storm intensity involves complex feedback mechanisms that researchers are still working to characterize. But the trend lines are not pointing toward less severe events. Coastal infrastructure along much of the west coast was designed and built in a different era under different assumptions about what the ocean would ask of it. Seawalls built in the 1960s and 1970s were engineered to specify tolerances. Those tolerances are increasingly being tested. Some structures are holding. Others, like the dock section in Ventura that broke apart on Saturday, are not. This week's event will end. The swells will diminish. The advisories will be lifted. Crews will repair what can be repaired and document what cannot. People will return to the beaches and the harbour fronts and the coastal roads, and the Pacific will look, once again, like something manageable. But the oceanographers will still be watching the data. The models will still be running. And somewhere out in the open Pacific, the next system will already be forming, already transferring its energy into the water, already beginning the long journey toward shore. The coastline will be there when it arrives. The question, the one that emergency managers and scientists and planners keep returning to, is what condition it will be in.